In this final episode of the online classroom, we're going to look at system evaluation, in particular the evaluation matrix, to help us decide which design we're going to go with. This is the final episode of the systems approach to a straightforward problem, keeping a lawn neat. System evaluation is really a process for decision making. Now that you've designed your system, we're going to revisit your customer requirements and evaluate the best option for your design. There are many types of evaluation criteria. You can rank them directly or using a weighting. You could go through a systematic elimination of designs that don't meet certain criteria. You could do a comparison across alternatives, so you could be picking the best of the options that are available to you, or you could be comparing them across a standard. You could also apply some mathematical techniques, such as the Laplace criterion, a maxi-min and a maxi-max criterion, or the Hurwitz criteria. We'll look at those in more detail in ENGN2225. For the purposes of evaluation today, we're going to take the weighted ranking option and look at a comparison across a standard. Remember the house of quality. We're now looking at the areas in red. So benchmarks and targets provide our standards, and the comparisons are going to be across 3 design alternatives. The 3 design alternatives that I've chosen are a petrol lawnmower, an electric lawnmower, and a manual lawnmower. You could choose to evaluate just one aspect of the design, such as the cutting system, or the whole design. In your project, you could put your design up against other alternatives. A key idea in the evaluation process in systems engineering is that it should be based on all the previous steps that you have done for your project. If we go back and remember our customer requirements, we decided design requirements based on those customer requirements. So when I'm saying we're looking for the one that meets the cuts grass requirement the best, I'm really looking at which has the most effective cutting mechanism, catches grass appropriately, and is safe for users and passers-by. Your customer has probably signed off on these design requirements early on in the project, so it's best that you stick with these when you're evaluating your design. You should also keep in mind the functional flow block that you had created for your design. This is the method of intended use when going about using your design. Based on the selections that we have, if we choose the manual option, it might actually improve the maintenance and reliability because there isn't an electrical or power system to check. You should remember your design attributes. So when you're looking at the cuts grass requirement, what are the attributes of cutting grass? How have we built that into our design? For example, if the customer requirement for cuts grass has been interpreted as effective cutting mechanism, fast spinning, which needs an adjustable speed, we need to be able to show that that happens within our design in order to give it a good response in our weighted criteria. For the purposes of determining which requirements are more important than the others, I go back to the pairwise analysis that we did. Here we found that cuts grass was the most important and spare parts was the least important, along with cheap. For the purposes of the evaluation matrix, I'm just going to look at the top 5 customer requirements. So let's construct our evaluation matrix. Here we're using the weighted criteria, so none of these requirements are classed as mandatory. According to the rank in my pairwise, they get a number in order from 1 to 5. This is translated into a weighting, where the most important gets the highest weighting. Note the scale that we're using provides a 5 for exceeds, 3 for full, 1 for partial, and 0 for non-compliance. For the durable customer requirement, I've given the petrol lawnmower a relative compliance of 3, which is full compliance. This is the same for electric and manual. You should be able to get the level to which your design meets the requirements through your testing process. When we look at the cuts grass requirement, the petrol and electric exceed the compliance, whereas the manual only meets the compliance. This is because sometimes you have to go back and cut the grass again. If we complete this for the whole matrix, if we complete this for all of the requirements, we start to see which design will be our preferred option. As low noise was a key requirement, the petrol lawnmower doesn't score very well. In fact, it's a non-compliant, whereas the electric is quite reasonable and the manual exceeds that compliance. Remember, when I'm providing a mark here, I'm using my benchmarks, so I would have gone back and had a look at what my benchmark noise level was and compared it against the attributes, and then used the attributes to help test that benchmark. Once you've completed the matrix, you can total the weighted value columns, and you end up with a preferred option. Here, largely because of the low noise requirement, the petrol lawnmower doesn't result in the preferred option. The electric and manual are very close and would therefore warrant further consideration with more customer requirements. For example, a manual lawnmower is going to be very difficult if the lawn that I need to mow is quite large. It might be worthwhile going back to the customer and asking how much lawn needs to be mowed. If I were to approach this in a slightly different way, the cuts grass customer requirement might need to be mandatory, and I might set the benchmark at a 5 for relative compliance. If this were the case, then I could eliminate the manual option immediately because it doesn't meet the cuts grass requirement to a high level. Likewise, with the low noise option, if I was using the elimination method, the petrol lawnmower would be discarded in the second round. A word of caution: don't just blindly choose the highest option. This quantitative analysis doesn't necessarily mean that you've captured the system properly. You need to interpret the results and use that to either improve your design or to improve the way that you communicate your design. When you assign a relative compliance, you should be sure that the product meets the test benchmarks for that design attribute. If it fails to meet that criteria and the customer requirement is very important, then you might need to eliminate that design. And finally, you need to make sure that your customer requirements are complete. Your evaluation is using your model of the system, which might not be exactly what the customer wants. So use this process as a way of communicating your design and then talking to the customer. A recap of the key ideas from the System Evaluation Online Classroom. Evaluation formally assists the design selection stage. Doesn't select a design for you. It's a way of showing the process in which you came to your best design. You could complete the evaluation at multiple levels. You could complete it at a tertiary attribute level, a secondary attribute level, a customer requirement level, a full system level, or just a subsystem level. A full and complete evaluation would consider as many of these ideas as possible. And finally, you should use the evaluation process to improve your design, not to validate how good it is. Because if you change some of the customer requirements, if the market changed, if their requirements changed, your design might not be the best alternative. Thanks for watching the online classroom series for ENGN2225. Make sure to check out the self-tests on Waddle and have a look at the core reading for the topic. We'll see you in the online classroom for 2226, which will be looking at the analysis of your design at greater detail. See you then.